Hey everyone, today we are going to solve LeetCode problem number 560. Subarray sum equals K. In this problem, we are given an array of integers and an integer K, and we have to return the total number of subarrays whose sum is equal to K. Okay, we are given nums array, let's say it is 111, and the second input is K, which is, let's say if I take an example, 2. So these two values are given to us and we have to return the total number of subarray whose sum is equal to this K value. So from this array, we have to give the number of subarrays whose sum is equal to this K value. Okay, so if we try to see on this array, we have to find sum 2, and let's say for this array, if I take first two elements and then I can say later two elements, the sum is coming 2. In it means that these two subarrays are valid and our sum is 2. This is one subarray, second subarray. Total we have two subarrays whose sum is 2. If you take another as subarrays, we cannot consider first and last element because that is not a subarray. Subarray should be a contiguous sequence of elements in a array. Okay, so even if we take whole three elements, the sum is coming to 3. So 2 is our answer in this case. Or if I have a look on this example where nums is 1, 2, 3 and k value is 3. So now from this array, I have to find all the subarrays whose sum is 3. If I take these two elements, first two elements, the sum is coming as 3. Or if I take this element only, 3 is also a subarray, its sum is also 3. So these two I can visually see, or if I take all three elements, the sum is going beyond 3. So I think these are the only two options. So yeah, 2 we have to return in both of the cases. Okay, so now let's come to the approach. How do we solve this problem? And before that, let me tell you that this is also a prerequisite question for this problem 1074, number of submetrics that sum to target. Here we are using a 1D array. Here we will be having a 2D array. Submetric with target sum, and here we have to find all the subarrays with target sum. So similar approach, but like a complex problem. Okay, now let's try to have a look on the first approach. Let's look for the brute force in this case. Here given array is 1, 2, 3. If I take a brute force, what I will do is I will get all the subarrays of this array and individually I will check sum. Let's say if I take 1, 2, 3 and 1, 2 and 1 only, like 2, 3, then 3 and only 2, only 3. These are the various subarrays or empty subarray that is not a valid one in this case. So let's say and here we will calculate the sum and then we will match if our sum is equal to k value. In that case we will increment our answer by 1. So this is going to be the brute force. So here how do we get all the subarrays? By using a nested loop. Let's say I is starting from 0 and it will go till n minus 1, and for every I the j value will go from I to n minus 1. Okay, so in this case we are starting, I'm starting from 1. So from 1, 1 is the subarray, 1, 2 is the subarray, 1, 2, 3 is the 1. And then if I start from 2, 2 is my subarray, 2, 3 is the subarray, starting with 2, and starting with 3, 3 is the subarray. So here in this case, I'm going to use two loops for I equal to 0 to n minus 1 and for j equal to I to n minus 1. In the n square time, I will be able to get the window of my subarray, and apart from that I also need to check sum of each subarray. So if I take, let's say if I take this subarray and I'm going to take sum of this, I have to iterate over all the elements in this subarray and then capture the sum. So to capture the sum we are also taking order of n time. So overall it is a order of nq operation. So the brute force approach is not very efficient to us, but yeah, we can build the intuition that we are generating all the subarrays and we are capturing the sum, whatever mentioned in the problem statement. So here, as we are capturing sum from left to right, so why don't we just take a prefix array? If I do not consider any element, the sum is prefix sum is 0. If I consider only first element, the prefix sum is 1. If I consider first two elements, the prefix sum is 2. Sum means the prefix of I is equal to the sum of element from where with the value I going from 0 to I inclusively. So prefix of, let's say prefix of 2, 0, 1, 2. Prefix 2 is going to be the from 0 to 2 values of sum of all the values from 0 to 2. So here at index 2 it is going to be 6. At 1 it is 3. 1 and 1 will be added to this 2 and it will come as 3. 3 will be added to this 3 and it will come as 6. So this is my prefix array, and if I take can I take use of this as this prefix? So yeah, our target value is already given, that our target value is 2, or let's say in this case take it 3, that our target value is 3. So here at every position, let's say at 1 we are at this position, so sum till this index is 1. So can we break any part from the left that will lead to this target? No, that is not possible. 0 means that subarray, this subarray, all the subarrays ending with 1. We are checking all the subarrays ending with 1. If I am at this index, it means I am checking all the arrays ending with 2, one index, and this is my prefix. If I draw here for 0, I am processing these array, and for one index I'm processing these arrays ending at this index. So for 3 this is not possible. If I come to index 1, index till index 1 the sum is coming as 3. It means I have to include all of these elements. It means that is possible, that 1 2 is making a subarray. And if I come here, the target sum is prefix sum is 6. It means till this index, till second index, the total sum is 6 and we have to achieve only 3. So if I subtract this 3 from our total target sum, I am left with 3. So any subarray ending with second index, if I drop sub part from the starting, I will can I get 3 as a target? Yeah, I have to drop 3 from the starting. So we will check whether the 3 is already present in it or not. Here I can see that this is already present. 3 is present here at this position. It means from index till index 1, if I drop the elements till index 1 from this array, so this array was like 1, 2, 3 because we were at index 2. So we were processing this array. So element prefix sum at index 1 is 3. So it means this array we have to drop and we have to consider only this part. So this part will give me 3 as the answer. Okay, so like we calculated the prefix sum in the on time, and then checking all the elements whether like sum prefix sum at I minus k is already present in the previous run or not. So for that we are also going to take on time. So in this way I see that it is going and scare, but we can further improve by not checking whether the sum minus k already present in the array or not. So if I take a hash map, let's say our array was 1 2 3. I'm taking a hash map. This is my or you can say hash array. I'm taking a prefix sum. Like I don't need to take a prefix sum array separately. I can track that in a single variable. Let's say prefix variable I'm using to store my answer, to store my prefix sum. So at index 0 the prefix value is 1, and we have to achieve k equal to 3. It means I'm processing subarray ending at index 1. The total sum achieved so far is 1. So it means that we cannot achieve 3 using this subarray. Let's just directly skip it. So prefix sum till index 1, it was 1 plus 2, 3. So prefix sum at this position is 3. So 3, like it means what we have to do is till this array. Till this array we found the prefix sum as 3, and what we have to achieve, we have to achieve 3. It means the remaining part is 0. Can 0 be available like in the left part? Yeah, if we do not include any element. Let's say if we draw a line here, it means including all the elements from 0 to 1 index. Yeah, I can we can achieve 3. So in that case this is available. So for that to tackle that case we also have to add 0 or 1. So that 0 sum we have one option, or maybe you can say one line for 0 sum. So one border for 0 sum, and for one first position for sum 1, yeah, we have one option so far, and for sum 3 we have one option. Okay, in this way we are going to develop our map, because in our map we will be checking prefix of I minus k, whether this sum we can achieve from the subarray we have already visited. If we can achieve that, it means our target is also achievable, and we can add 1 to our answer. Otherwise we cannot do anything. Okay, so for if we come to the third index, which is I equal to index equal to 2, we our prefix value is going to be 6. Okay, so for 6 it means that from 1 to 3 from this array we have achieved sum as 6, but we wanted to have 3 as our target, so 3 is remaining one. So have we visited any sub array whose sum is 3? Yeah, there is one possibility where sum is 3, which is this line. So we can discard this one, and we can achieve this result. It means that one case is available, so we will add 1 to our answer. Okay, so in this approach I have taken a prefix variable which is nothing, just O1 space. Apart from that I have taken a map, that is while iterating through this array I'm tracking the prefix value and adding the value to my map. In my map for this sum we have one possibility and two possibility and so on, number of possibility, or you can say number of incident. Okay, so in this way we are doing one iteration And while doing the iteration, we are keeping track of this map and the prefix sum, and we are not coming back to any already visited position. So in this way we are going O and time. So the time complexity for this approach is order of n. And what is the space complexity? Space complexity is also order of n, because we are taking an extra map. So here we improved our time from n cube to n square to n. So n is the optimized approach where we have used HashMap, and n cube is our brute force, where we explored all the possibilities of subarrays, and then we checked whether the target sum can be achieved by that subarray or not. Okay, it means that this operation takes order of and time. So if any in any position in any example, let's say if we are going to solve this problem and we have to like get subarrays where the target sum is equal to k, so we can directly do that in order of n time. Okay, so let's also write a code for that. You will be able to understand in a better way. Okay, let's write code for this problem. 560 subarray sum equal to k. We will iterate over this array I equal to 0, I less than n, I plus plus. Here I am also taking a map of integer map is equal to new hash map. This map I'm going to store that the sum value and the number of incidents the sum has already occurred. Okay, I also need to capture the sum 0. So for that I will make an entry map.put 0 1. That 0 has one occurrence. 0 is the case where the subarray is starting from 0 index and going till ith index. And to store our sum prefix sum, let's take a prefix variable and store my answer. I'm taking an answer variable. Okay, and in the end I have to return answer. So in the prefix, first of all we have to store my current element, prefix equal to nums of I. Okay, now we have to see whether ending at ith index I have a subarray whose sum is equal to this k value. So for that, to achieve the value k, we need to make sure that there is any subarray starting with 0 index whose sum is equal to sum prefix minus k. So if map dot contains prefix minus k, here it should be contains key. If map dot contains key prefix minus k, it means yeah, we can add something to our answer. The number of occurrences this prefix minus k sum is there, because that is the number of time we can get any subarray. So map dot get prefix minus k. Okay, otherwise add value to the sum, or to the map dot put prefix. If prefix is already there, increment the value, otherwise add 1. So for that I can use get or default. If prefix is not already present, entry with the prefix is not already present, it means prefix is coming 0th time, and now this time it has increased to 1 unit. So we are capturing prefix sum. We are seeing how many times we can achieve prefix minus k from the starting, so that we can discard that element and we will be able to get k. And otherwise I will put an add an entry using this prefix to my map. Okay, let's try to test our sample test cases. On the sample test cases it is working fine. If I submit the problem, it's submitted successfully. So we are returning number of subarrays whose sum is equal to k in this case in the order of n time. Hope you understood the problem. Thank you guys.